All right, here we go. So, basically, here's your prac sheet. So I made this for you so you could go through some things. The link up the top is my old magnesium prac discussion. But since I thought I'd just film this one, it's a few years old and some of the things don't quite match up. So there'll be a new link, but if you want to have a look at the other one, you can. This is your magnesium report helper. It's basically there for you to fill in like a rough copy and then do it. Very similar to how we did the flame practical. Okay, so the aim I'm going to give you today. So the aim of your experiment is to see what happens when we heat magnesium. Write it down. Okay. The other way you could have written it, to investigate what happens if we heat magnesium ribbon. The marks assigned for this will be 0, but it still needs to be there as a part of your report. Okay, so that's why I'm giving it to you. Your hypothesis. So, Kalel, can I ask you a question, mate? There's no right or wrong answer to this question. Do you think it's going to get heavier or lighter? Heavier. Okay. Anybody think it's going to get lighter? Yep. Okay. So all you need to do is write down why you think it's going to get lighter. You burn a piece of wood. Does that get lighter? I don't know. You're going to have to make that decision yourself. It's called a hypothesis because you're just having a guess. Okay. So it's an educated guess. So say, I think it's going to get heavier, and then tell me why. All right, now the why is not, I cheated a little bit and looked at the experimental results and found out that this happened, but I'm not going to tell you what happens in this experiment. So your hypothesis, an educated guess. Is it going to get heavier? Why? Is it going to get lighter? Why? Who said it was going to get lighter? Okay, can you give me a reason why? Yeah, okay, burning stuff away, it disappears. Could have released energy. Okay, so that makes it lighter. Now, they're all valuable answers that I want you to put in there. Okay, so I don't care if you're wrong. It's not about that. There was a few hands like this. There. It's either yes or no. Be proud of your answer. Equipment. So it says on the sheet there, dot points for this section. List each main item. You guys took a photo, and I made you take a photo so that you can write down the different pieces of equipment that are there. So you can come back to this when you're writing it up for your good copy. You can also include that photo, but I do want the equipment written as well. So you can have both. Notice it says dot points for this section. So dot point tripod. Next line, dot point clay pipe triangle. Next line, dot point Bunsen burner. Don't just dot them all in a big like hoggledy-poggledy. It's not connect the dots. Method. You'll notice there it says write in third person. You don't need to. Dot points for this section. So tell me what you did. Remember once again, it's not the case of dot open science room door. Dot move to bench. Dot looked at partner. Dot decided who was going to weigh things. Just simple steps so that you could actually repeat this experiment yourself. Okay, so if I asked you to go down to the lab and do it now without my guidance, someone could read your method and go and do it reasonably well. So results. Now there's a fake table there that you could use. If you don't like the look of that table, you can use your own. So let's go through your results. Brady. So what was your weight before you heated it?
54.995 grams.
Okay, and what was your weight after you'd heated it?
55.246 grams.
So has it gone up or gone down?
Up.
Up, okay. Rightio. Anybody else find the same thing with their results that work? So look for your results now. I'm going to just pick a random group. Yours went up?
Yeah.
Whose didn't work? Some groups didn't work. If yours didn't work, that's fine. Write that in your results. Okay, it just didn't work.
Our weight went down.
Your weight went down? Okay. So I reckon that we've had some type of error there. Because it should go up. And I'm going to explain why it went up there. Look, hey. Sometimes we make these errors, and this is why that third paragraph is there. It's okay. It's not the end of the world. Please don't fight. Who could tell me an observation that they made from this experiment? It glowed. Brilliant. You could also put a photo of that observation in there. those groups that didn't work, you could go to other groups and ask for that photo and say, this is what should have happened within my experiment. Just because it doesn't work doesn't mean that you can't write about what happened in other people's experiments. That's why I got one of your group members to come down and have a look. Some of you got videos and different things, fine. Turn them into photographs. That's where they go in that observation section. Right, turn the back of the sheet. Okay, so what does this say? Discussion, and then up the top, what is there in bold?
The majority of your marks is in that section.
Exactly. Okay, so this is where the majority of your marks are going to be. You still have to do the other things because that's what every scientist has to do to write a report. But the majority of the stuff I'm going to want to see is written in these 3 paragraphs. What's the first paragraph about?
The science behind it.
Brilliant. What's the second one about? So be specific. Give me specific weight. So what was your weight before it was weighed? Okay. So before, like, put that number in, and then tell me what it was after.
Oh, 55.3.
Brilliant. And then tell me the difference. The difference is this. Okay. So take those 2 numbers away. Tell me what the actual change in weight was. That's what I mean about being specific. Okay. Now the results section for this is not going to be very large. So let's talk about that now. When it says notes, what did I tell you just then? Specific actual numbers. So write that in your notes. We want the numbers. Okay, so this is paragraph 2, the results notes. I want the numbers. I want to know how much it's increased. Okay, I want to know the specific grams of what's been added. And then I'm going to talk about paragraph 1, which is going to take us a while. All right, here we go. Tell me when you're ready. I'm ready. Okay, thanks, guys. Thanks, Molly. Okay, up on the board is a picture.
You may draw
Not at the moment. I prefer you just listen. You'll find it on the internet anyway. I'm just gonna. Well, actually, I'm not moving the chair out of the way so I don't cover it. You'll find this very easily. So what you actually did today was you made a compound called magnesium oxide. Okay, I'd write that down in my notes. Magnesium oxide. I'll write up on the board.
Where do we write that?
In your notes section for the science, magnesium oxide.
Yeah. Maybe one.
So, what you did is when you heated up the magnesium and then you opened up the lid, you allowed oxygen to move in. And so that means that the reason it gets heavier and the reason why I found it difficult to explain that it gets lighter is because you're adding oxygen to the magnesium ribbon. When you add something, things get heavier or do they get lighter? Hi, Wendy. No worries.
I sent you an email, but you must have seen it.
I was at the science lab, sorry. Okay, I was at the science lab then too, Wendy. Come on, Zach Bassett.
Good try.
I tried, Wendy, I tried. You're on a video now, Wendy, by the way. I don't make those mistakes. Anyway. So, what actually happens is that if we look at magnesium as an element, it's the 12th element on the periodic table, which means it has 12 protons and how many electrons? 12. Now, who remembers this word from last week? The word octet.
No.
Okay, 8 electrons. It's a very stable configuration. If we look at magnesium, we see we've got these 2 outer electrons. But if we go one cell back, or one shell, should I say, you find we have 8 electrons, which is called a... Every element wants to be that octet. And it will do it by either giving away electrons or accepting electrons. Now, as soon as it gives away or accepts electrons, it's no longer an element. We call it in science a ion, okay, or a charged particle. So what happened in your experiment is oxygen wants 2 electrons. Funnily enough, magnesium has 2 electrons to give away. So oxygen comes along and rips those 2 electrons out of magnesium's outer shell. And so what happens is that this is what they're like with elements. So this is before you heated it. You open the lid, nasty oxygen comes along, steals these 2 electrons, and they change from an element to a ion. Now, if we have a look at magnesium there, it will have now still got 12 protons, but if I add in the electrons, it's got 2 less. So now it has 10 electrons, so 10 negatively charged electrons, but 12 positively charged protons. So how many more protons does it have than electrons? 2. And protons are positively charged. So we call it a +2 ion. Plus, because it has more protons, and 2, because that's the number it has more of. If we go and have a look at oxygen, it had 6 in its outer shell, but it's got 2 now from magnesium. So it had 8 protons in its nucleus, but now it's got 10 electrons. So how many more negative charges than positive charges? 2. So we would call this a -2 ion. This is because it's got more electrons, and this is the number. Now we use this a lot in science. So if I had -3, does this have more protons or more electrons? Nah. Minus means more electrons. How many more electrons does it have? 3. Brilliant. What happens if I wrote +1? It has more protons. How many more protons? 1. Okay. Now you noticed the other day when I got you to do that periodic table, I got you to write +1, +2, +3 across the top. And then we got the plus and -4, and then we did -3, -2, -1. Now you understand what they mean. If it's a minus, they've got more electrons, and the number is how many more they have. So, when we put this together, we get this compound. Now, why isn't it called, well, it's magnesium's fine, but what's happened to the oxygen? It's become an ion. And we're going to do this in class on Wednesday, so don't panic. Yeah, Wednesday, we're going to do this on class. You guys are just a little bit ahead of everybody else. Okay? And a better class. Got that on video, so we can use that. All right. So, if we have a look, can someone go to the science behind that stuff on that paragraph and tell me what were some of the things that I wrote? Have I talked about the difference between an element and an ion? Yeah. Told you that elements are non-charged particles, so they have got these outer electrons, but when they let go of them or take them in, they become a ion. I've also written this word. What's that say? Charged particle. Okay. Valency and outer electrons. Well, how many outer electrons does magnesium have? 2. So that's why we call it a +2. That's its valency. All right. So now we're going to write down an axiom of science. Who knows how to spell the word axiom? Axiom of science. Right, you ready? Like, oh sorry, oh wait. Ready to go? Anywhere you want to write on that science? Like charges repel. Like, yep. Unlike charges attract. Like charges repel. Unlike charges attract. So the easiest way to explain it is a magnet. What happens when you get a north part of a magnet and the north part of a magnet? They repel each other, don't they? Because the charges are alike. Now, if I got a positive charge and a positive charge, what do you think they'd do? Are they the same? So they will repel each other. So if I shot a proton at a proton, they would repel each other. What happens when you flip this magnet up here and you make it a south? So, I'll show you what it does. Here we go. Okay, they attract to each other. And so, if you've got a north and a south, or unlike charges, they attract. These two up here, of course, repel. So what do you think if we have a positive and a negative? What happens? They attract each other. So notice we've got a big positive ion magnesium and a big negative ion oxygen. So will they repel or attract each other? So they kind of go boom, and they form a compound. And they form a compound because one's positive and the other one is negative. Now you know this, you've seen it with magnets yourself. That's what's going on here. So as magnesium gets rid of its electrons, and oxygen basically more or less comes and takes them away, one becomes positive, one becomes negative, and all of a sudden they can't stop it. It's like two kids at a leavers dinner, bang! Attraction occurs. They're stuck together. Horrible stuff. Horrible stuff. But basically, that is the case. So that's what's happening today. Magnesium is losing 2 electrons, makes it positive. Oxygen gains 2 electrons, makes it negative. And the two can't stop it. They just can't help it. Bang! They get attracted together. Thanks, Joe. I like that thing too. So that raw attraction between these two we call an electrostatic bond. Now that is how anything that is made of ions will bond together, and we call it ionic bonding. Okay? Because it's between 2 ions. So that's what you did today. By heating it up, you gave enough energy for these 2 electrons to be far away. Oxygen took its opportunity, took them away from magnesium. One becomes positive, one becomes negative. Bang. It happens. It's on. Magnesium oxide is made. All right? That's more or less it.
Thanks.